This set of notes covers a section in your book called What Happens to the Volume of a Gas When Thermal Energy Changes. At the top of your paper, you should put the date. For in-person students, we completed these on Monday, November 2nd. Remote students completed these on November 3rd, which was a Tuesday. At the top of my paper, I'm going to put the heading, which is the section of the workbook. What happens to the volume of a gas when thermal energy changes? So the first thing that we need to go over before answering that question is a little bit of a history connection. When you read the text yesterday or had the text-to-speech read it to you through the online curriculum, you should have learned about a French scientist named Jacques Charles. Jacques Charles lived from 1746 until 1823. And as I had said, he's a French scientist, or was a French scientist. I'm going to highlight his name since he's an important person, and he's important to the field of science because he described a relationship between temperature and volume of a gas. So the work that he did led to the acceptance of this law called Charles's Law. In science, a law is not like a law in our daily life. A law in science is like a proven, it's like an accepted fact. So Charles's Law will apply all the time. And his law stated the volume of a gas increases with increasing temperature. However, he did say that this happens as long as pressure stays the same. We'll get more into pressure in a later lesson, but it's part of this law in our current lesson, so I'm going to add that on there. So now I'd like to give you an example that helps to kind of visualize Charles's Law. You may want to watch what I'm doing before you set up your paper. In the middle of my paper, I'm going to write the word example so it sets apart this section of my notes. And then I'm going to draw a square in the middle of my paper, maybe like 1.5 inches by 1.5 inches. And then I'm going to draw a second square to the left and another square to the right. Between each square, I'm going to draw an arrow. So we have box 1, box 2, and box 3. Each box, I'm going to draw a balloon in each box. Try to draw your balloons about the same size and shape. And I'm going to label the top of the boxes. This balloon is inside or indoors. Then we can imagine we're taking it outdoors and finally bringing it back inside. So I have 2 indoor balloons and 1 outdoor balloon. Inside, the balloons are 75 degrees Fahrenheit. So both indoor balloons are 75 degrees Fahrenheit. The outdoor balloon, let's say this is 30 degrees Fahrenheit. Now inside each balloon, I'm going to draw air particles. The indoor balloon is well inflated, so those air particles should be spread out pretty far. The indoor balloon, as the temperature around the balloon changes from a high temp to a low temp, this balloon is going to become deflated. As the temperature gets colder, the air particles get closer together and the balloon looks deflated. Then when we take the balloon inside again, it will appear to get larger and re-inflate itself. So these air particles would be far apart again. There are a few important facts about these balloons. I can't fit all the information between the boxes, so I'm just going to draw a line down here and do a few bullet points. When the balloon goes from the inside location of 75 degrees Fahrenheit to outside at 30 degrees Fahrenheit, the temperature decreases. The air inside the balloon slows down. And the particles get slower, so they're moving more slowly. And as they're doing that, they're not bouncing around as much, so the particles are getting closer. These 3 bullet points summarize the definition for thermal contraction. Contraction means to be made smaller, and thermal has to do with heat. This process of the balloon becoming somewhat deflated is caused by the change in heat. So the balloon contracts due to the change in heat. When we take the balloon from outside and bring it back inside, the temperature increases, the air speeds up, and the particles start to move apart. And this is called thermal expansion. So at this point, this wraps up your notes. I'd like you to go back to class pages and see what else you need to complete for today's assignment. I will let you know that there will be a short check-in quiz about these notes on Thursday. You'll be able to use your notes for the quiz, so make sure you have them with you.